All right, we left off here, and I was typing and I got cut off. So let's go back to it for a second. So we want to know the probability of bankrupt or lose a turn twice in a row. So the probability of bankrupt or lose a turn is 3 out of 24, but you want to do it twice in a row, and of course they're independent. So you just multiply 3 out of 24 times 3 out of 24. And then I went over to Excel to figure out how to do that. So I type equals 3 divided by 24, and then close my parentheses, and then shift 6, which is the caret button, 2. And there we go. It's 0.015625. And yes, I know you could multiply it out and get 9 over whatever 24 squared is, but it's irrelevant. Okay, there we go. All right, suppose President Obama's approval rating is currently 62%, which is not, I made up the number. So you're going to poll 5 random people by phone. Are the 5 people you poll independent of each other? Well, it's kind of a good question. It depends, but most likely yes. Right? The chances of calling people who will affect other people is slim. So, for example, how would that look? How could you get somebody to affect somebody else's vote? Well, if you got called by CNN about a survey, and then you picked up the phone and called your cousin and told them about the survey, and then CNN actually happened to call your cousin about that same survey. I mean, it's really, really, really slim. Really, really slim. Okay? So, because it's just not likely that they're going to call family members. They will call people who are in the same family. Oopsie. Or circle of friends. I mean, they only call 1,000 people or so. And there's 300 million people in America, so they're not going to be hitting a lot of overlap. As a matter of fact, I'll write that. Cool. All right. In other words, the way you answer is not going to affect the way the next person they call answers, and so on. All right. What is the probability that the first 3 people approve of President Obama and the last 2 do not approve? Ooh, so we're going to call 5 people. So let's write that out. Probability: first 3 approve, last 2 do not approve. Okay, well, all these people are independent of each other, right? So we can just multiply. And the probability that the first one approves is 0.62. Probability the next one approves, 0.62. The probability the third one approves, 0.62. Fourth one would be well, you have to use the complement rule. 62% approve, so you're assuming 38% do not approve. There you go. Now, we don't want to do this by hand. It's yuck. But let's see if we can make it so Excel does it. Never mind. I was going to be cutesy, but it's not going to let me do it. Yeah, I know. Hold on. All right. I fixed that problem. So it's equal 0.62 times 0.62 times 0.62 times 0.38 times 0.38. Yes, I know there's ways you could do that with the caret thing. Oopsie. There it is. If you wanted it more fancy, you could type parentheses 0.62 close parentheses to the third times 0.38 close parentheses to the 2. Oops, and press enter. Don't do it. There we go. Same answer. Okay, so it's 0.0344. All right, if you were going to ask 100 people, how many would you expect to approve? Well, that would be 100 times 0.62, which would be 62 people.